3.4 is graphing functions. So I think the easiest way to kind of do this one is just to show you some examples. So we're going to go straight to the evaluate section. In class, I'll talk about some different things here with the calculator that will be beneficial to you. But for right now, just going to go again to the evaluate section and we'll start doing some problems. So we're going to start with problem number 1. It says graph each function for the given domain. So remember, domain are our x values. So these are all x's right here. And all we're doing is we're taking each of these values and we're plugging it into the function. So again, we learned about function notation. This is where this would be a little bit easier. They're giving it to us as y equals, but it doesn't really matter. So if I do y equals 2 times -2, then that is -4. So what I do, I go where x is -2, which would be over here on the left, and then I go to the y value, which is -4. So that gives me a point. The point is -2, -4. That was the x, and this is the y I ended up with when I plugged it in. And all I do is I do that for each of those. So if I plug 0 in, I get 0. If I plug 2 in, I get a +4. And if I plug 4 in, I get a +8. Okay, so this is a discrete function in this case because we're just doing it for the given domain, just those 4 values. So we just end up with 4 points. Okay, let's scroll down to number 5. One thing to note here, always read directions for the given domain, okay? Because down here at number 5, it says graph each function. So here we are going to graph the function, but we're not given a domain to set it on. We're just graphing the whole function itself. So one thing you can do here is the same sort of thing. We're going to use a table of values. So I'm going to set up a table here. You can do it as x and y. And then just choose values. Now, the values you choose can vary here, but you want them to fit on the graph itself. So always look at the graph they give you. So for example, I wouldn't want to pick an x that was 15 because that's not on here. And in fact, I try to pick relatively easy values. So I'm going to start with 0, and I always put 0 in the middle here. So I'm going to pick 0. So if I plug 0 in here into the function, so 0, that's just 0, so +5, so I get +5. Now the reason I put 0 in the middle is because I want to go on both the negative and positive side here. So then I'm going to do -2. Now, why don't I pick a -1? Well, because if I look at my graph, they're going by 2's. So let's pick -2. So I'm going to plug -2 in here. So -2 squared is a +4, but then that's a negative. So -4 + 5 is 1. And again, I'm going to show you some tricks here to do this on the calculator. Not really tricks, but ways to do this on the calculator. So a +2 will give me 4 negative, and it's also going to give me 1. I'm going to do one more here. Let's try -4. So -4 squared would be 16. Take the negative of that. It would be -16 + 5 would be a -11. Okay, so I go to -4, -11. Well, here's the problem. That's not going to show up on the graph. I can get kind of close. So +4 would give me a positive, or also give me a -11. And I'll explain that a little bit more later on. So all I do is plot these points. So I go to 0 up to 5. Now where would 5 be? Right in the middle. Okay. Then I go to +2, +1, again in the middle, -2, +1, right here in the middle. Go to -4 down to -11. So that's going to be a little bit past right down here. And then +4, -11, a little bit past. So what I do is I connect my points. So in this case, this is going to be a curve. Okay, it's not a very good curve. Let me see if I can do better connecting my points here. That's a little better. Okay, we call that a parabola. And we'll learn more about that later, but all we're really trying to focus on here is how you graph. Let's go to problem number 11. It says use a graphing calculator to find the value of f of x when x is -4 for each function. So this again is how you'll need to just kind of listen in class. I can't really do this. One thing that's happened in problem number 11 here in the book, it's missing a parentheses there. Those are supposed to be there. But all I do is f of -4. So that means I put -4 in square minus 3. -4 squared is 16 minus 3 would be 13. That's what you should get. 15 says graph this, then find the value of f of x when x is 0. Okay, so how you're going to graph it. Again, I'm going to do a table of values, and in fact, one of those values is going to be when x is 0. So I'm going to go and put 0 here, just like I did in problem number 5 when I was doing it. So if I plug 0 in for x, that's going to go away. So that's 0.5. So at 0, it's 0.5. Now if you want to, go ahead and graph that point. 0, 0.5. 0.5 is just barely above that, because again, it's going by 2's. So I'm going to try values again. So I'll try -2 and 2. So if I do 2 in there, 2 squared is 4. 4 times 2 is 8. So 0.5 minus 8 would be a -0.75. So at 2, it's a -7.5. -7.5, sorry. So at 2, -7.5, which would be somewhere right about there. At -2, I'm going to get the same thing. And I'll tell you later on how I know all that, but you can do it again. The calculator is going to be helpful here, so I'll put the point there. Okay. I could try 4, but I have a feeling it's going to go off the graph, and the reason is 4 squared is 16. 16 times 2 is 32. That's way, way too big. But this is all I need to get my curve anyway. So if I graph this, there's my curve, my parabola, I called it earlier, and there's my value for 0. Okay, let's do problem number 21. Let's see, next page, sorry. There it is. Okay, problem 21. I'm going to make this a little bigger, help me graph a little bit here. The temperature in degrees Fahrenheit of a liquid that is increasing can be represented by the equation. Now here's function notation, f of t. They're not using x, they're using t, but that's okay. Graph the function to show the temperatures over the first 10 hours. Use the graph to find the temperature after 7 hours. Okay, so the first 10 hours. So what I'm going to do is, again, I'm going to create a table of values, but in this case I'm using t and f of t. And I'm just going to go in order here, so I'm going to do 0. If I plug 0 into the equation, I get 64. These are going by 2's on the x-axis here. These are all by 2's. So I'm going to go by 2's in my table. So if I plug 2 in, 2 times 4 is 8. 8 plus 64 is 72. Okay. And it says go up for the first 10 hours. Okay. So I'm going to do one more, and then I'm going to show you something. So I do 4. 4 times 4 is 16, plus 64 is 80. So at 0, I'm at 64. Okay, and where's 64? I'm not exactly sure, but maybe somewhere like there. At 2, it's 72. So 72 is a little bit higher. Okay, it's kind of hard to get a measure on these because it's going by 20s on the y-axis, which I don't really like. 4 is 80, so that would be right there. Now, all I have to do is connect these until I get to 10 here, because this is going to be a straight line. Sorry, that didn't start very well. A straight line until I get to 10. Okay. Now I could keep doing that, and if I did 10 here, 10 times 4 is 40, plus 64 would be 104. Okay, so I'm just above 100, because remember this is 100 right here. So that looks pretty good. Obviously you want to have a ruler to do this, and we're going to start using rulers a lot in class when we start graphing. It says, but use the graph to find the temperature after 7 hours. Okay, where would 7 be? Well, this is 6, here's 7. So I go up on the graph, there's 7. Okay, now where is that? I don't know, 90 something. Okay, it's kind of hard to tell on the graph. It's not real clear. The best way to do it is to use the function. So f of 7 would be 64 plus 4 times 7. What's 4 times 7? 28. So you get 64 plus 28, and you get 92. Okay, which is kind of hard to tell on the on the graph because it goes by 20s, but you can kind of tell where it is. Let's do one more problem. Let's do problem number 23. It says, again, one of these error problems. These are always good. Student A and student B were given the following graph and asked to find the value of f of x when x is 1. Okay, so let's go where x is 1. Okay, again, they're going by 2's here, so 1 would be somewhere like right there. Okay, there's 1. Student A gave an answer of 0, while student B gave an answer of -2. Okay, so let's go a little bit closer here and look. So I'm going to make this graph a little bit bigger. So halfway would be like right there. Well, it's not at 0 because the graph is not touching right there. If I actually go down, it's like right here, which would be at -2. Okay, so let's look back again. Student B gave an answer of -2. Who is incorrect? So the student who's incorrect is student A. Okay, why are they incorrect? Because at 1, it doesn't actually, it's not at 0. That's not where it crosses the x-axis. Okay, at 1, if you go down from there, it goes to -2. So student B is the one who's correct.